Good morning, students. By the way, my name is R.RajiniGanth, belong to the Department of Computer Science Engineering. Today we are getting into the compiler design concept, and we are going to see what is a compiler, what are the phases of the compiler. As a third year student, we come to the idea what is a compiler. Compiler is a system software which convert the given program to the machine understandable code. Then what is a computer? Computer is normally an electronic device. What is a machine understandable code? Normally in the form of zeros and one. And it is very tedious for the human beings to write everything in zeros and one. So we need compiler. For an example, if you are going to write a factorial program in a C language, it need to be understood to the system. So in such case, what happened? The code need to be understood to the computer. So in such case, we need a various compiler. Presently, what happened? We have the advancement of the technology. We have the online compiling tool, virtual compiling tools, and program is n number of compiling options are available. You know what is happened? Compiler is a program, system software program, which takes the input from the user and make the things to understand the system and produce the target output. So we are getting into the phases of the compiler. Normally, what happened? See here, the various phases of the compiler should understand its system program and make the things to be understandable to the system, and various forms of the compilers are available. That's a C compiler, Java compiler, C++ compiler, VB compiler, and a number of options are available. So see here, then before getting into the compiler, you should have an idea what is an interpreter. Compiler is a program which takes the whole segment of the line, either 10 line, underline, or any form of the line, and make the system to understand. So the whole program will be compiled at a single execution step. But interpreter is a program, again system program, which compiles the things by line. Look to the diagram. See here how the compiler will be compile the things and produce the targeted output. Source code, a compiler, any form of the compiler, and produce the output to the machine, and machine codes are generated. What is the machine code? Normally zeros and one. But see here how the interpreter, it checks the things by line operation. What happened? Line by line operation. Now see here, when an expression is going to be evaluated. Now we are getting into an expression which is called position. Take an example. Position equal to initial plus rate into 60. When this expression is going to be compiled by the compiler, it will be checking what happened. Position, assignment, initial plus rate into 60. So the compilation process, the compiler, various phases of the compiler. The compiler phases are divided into various phases, such as what happened. The compiler provided with a symbol table. What are the various phases? The compiler phase, Lexical Analyzer, Syntax Analyzer, Semantic Analyzer, and then intermediate code generation, code optimization, and code generation. So these are the phases of the compiler. What? Because the compiler is a huge program, we cannot write all the program in a set of 1000 line or maybe a 1 lakh line at a single task or a single function. So in this case, what happened? Compiler is divided into various phases, such as compile, the phases of the compiler. Lexical Analyzer, Syntax Analyzer, Semantic Analyzer, intermediate code generation, code optimization, and code generation. The compiler will build with a symbol table. What is the need of symbol table? All the phases of the compiler are linked to the symbol table, followed by the compiler will be having another substitute called an error table handler. What is the mechanism? Error table handler. So the compiler will be having a truth table such as symbol table and error table and various spaces of the compiler. Now you come to an idea why the compiler getting into the various spaces. It's a big program. So in this case what happened? It's a compiler. But what happened? Interpreter also a program. In this case what happened? It will be checking the things by line. Here whole segment will be taken and output will be produced. What happened? Whole segment will be getting and output will be produced. So we can come to the idea what happened? How the compiler will be compiling? Here the parts of the compilation is divided into two things such as analysis. What happened? We see an example, position equal to initial plus right into 60. So the analysis phase will be getting in and followed by how to generate a tree. What is the need of a tree over here? Because when expression is going to be evaluated, we will be finding what are the various operand and operator. More or less you are very familiar what is operand and operator. Operand is a variable names given to the program. Operator. Each and every language will be having its own operator to its operation. And synthesis. And from the generated tree structure, it will be forming of a target program. So the model of the compilation is divided into two places such as analysis and synthesis. See, just now I gave an idea, the same diagram in terms of the picture. Symbol table manager, lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generation, code optimization and target generator. The phases of the compiler. And followed by compiler is linked with the symbol table and an error table handler. So again what happened? The compiler is divided into two phases, front end and back end. What are the front end phases? Lexical, syntax, semantic and then intermediate. And back end phases such as code optimization and then target code generator. What happened? See the diagram very well. So the compiler is divided into various phases to make the task. What task? Make the things to understand to the system with the help of the various form. What happened? A symbol table and error table handler. Now see, each and every phases will be doing its own functionalities. So we see what happened in expression. Lexical analyzer will take the expression and split it into a number of tokens. When the token is given as an input to the syntax analyzer, the tokens from the lexical analyzer will given to the syntax analyzer module, and the syntax analyzer module will generate a parser tree. The parser tree be either in a top down approach or bottom up approach, either from of the down to, that is bottom to top or top to bottom. Now parser tree is generated. Now what happened? The things is getting to the next phase, semantic analyzer. Because what happened of the tree in the semantic, grammar will be said. What is the need of the grammar? Because without a grammar, what happened? The rules, automata and other things cannot be derived. So what happened? The semantic analyzer will be getting the input from the syntax analyzer as a parse tree and produce a semantic validation. And intermediate code generation will be a some other form. And again, what are the some other forms? Some substitution will be given to the operands. And followed by code optimization will be checking any other of the code redundancy occurring of the generated code. And targeted codes are generated. So look to the diagram. The compiler phases are divided into two phases, front end and back end. Followed by compiler will be as a substitute as a symbol table manager and error table handler. What happened? Symbol table manager and error table manager. Now we are going to take an expression. Just we see that initial. Again what happened? A string such as this is the input in a C language. When you are going to compute the addition operation, A equal to B plus C. Everyone know it very well. How the operations are performed? This is going to be performed by the what? Compiler. When A equal to B plus B given as an input to the lexical analyzer, what happen? It will be checking what are the tokens. A, B, C are the new variables, which is considered as a token, and plus and equal to are the stored symbols of the language. What language? C language. What happened? Because A equal to B plus C semicolon. It is a syntax of the C language. Now the tokens will be passed as an input to the second phase of the compiler. What are the phases of the compiler? We know it very well. Lexical analyzer followed by syntax analyzer. When the lexical analyzer take the expression A equal to B plus C and pass to the syntax analyzer in the form of token. Now the syntax analyzer will be forming a tree. How the tree will be formed? Because see here A equal to B plus C. What happened? Quite simple. A equal to B plus C. In this connection, what happened? See, the expression is A equal to B plus C. When the first phase of the compiler will be getting, and what happened? It will be finding the expression A equal to B plus C. A symbol table will be generated, or the things will be passed to the symbol table. What are the information? The symbol and other things are already available. Operators is not needed. A, B and C, which are the unknown things to your computer or to the compiler. It will be put into the symbol table. The new symbols are A, B, C. So what happened? So it generated three tokens, A, B and C, and stored in the symbol table. Got it? Now the tokens will be given into the syntax analyzer. Now syntax analyzers need to generate a parser tree, because with the help of the parser tree only it is going to generate a grammar. The grammars are two types. We will discuss in the coming session. But what happened? Now what happened? A equal to B plus C. So it will be what happened? Assignment followed by a plus followed by one more link and one more link. C, B, A. A tree is formed. We know what is the tree in a data structure. Again with the same concept, the syntax analyzer forming a parser tree. This tree name is called parser. What is a parser? The parser will get the information token from the lexical analyzer and generate a what tree? Parser tree. The parser tree two types. What type? Bottom up approach and top down approach. When it is going to be generated the things from top to bottom, it will be called top down approach. What, my dear students? Top down. Followed by, we have one more terminology which is called bottom up approach. What happened? Bottom up. Top down, bottom up approach. Just remember the addition expression A equal to B plus C, quite simple program, because what happened? Simple instruction and a single statement. So the parser is getting again from the semantic, the substitutes will be formed. What happened? The various substitutes will be getting involved. What are the various substitutes? Listen. So what are the phases of the compiler? We know it very well. And followed by, when the expression is getting involved, what happened? The various things are getting in. So we know what are the phases: lexical, syntax, semantic, followed by intermediate, code optimization, and then code generation. Look to this expression A equal to B plus C. The lexical analyzer is also called as a scanner, which take the expression and bit into token. C such as A, B, plus and etc. also getting in, and semicolons also split as a token. But I am not given the things in a single table in the during my computation, because assignment operator, plus operator, semicolon are the symbols in the C language, you know very well. Symbols, and remaining A, B, C are the token. Got it, my dear students? Fine. After the lexical analyzer, we moving to the next page, lexical syntax analyzer. In the syntax analyzer, what happened? It is going to be generating a tree structure. Just now see what happened. The syntax analyzer or the parser is getting all the things from the token as a tokens are generated in the lexical and passed to the syntax analyzer. Syntax analyzer will be generating a parser tree. See here, assignment. Just we see that. Left assignment A and again followed by a symbol. What expression? Because A equal to. What happened? Because the expression is what happened? Quite simple. What is the expression? Expression equal to is just very simple. A equal to B plus C is the expression. What is the form of this expression? We need to get the values B and C from the user and just add it and supply it to A. The what happened? Append value or added value, sum up value, and assign to A. Got it? Fine. What happened? For that, A equal to B plus C. It is getting in followed by an assignment operator, a left string. Left assignment equal to left assignment A. The right what happened? We have operator plus followed by it has two strings such as B in the left, so C. This is called parser. What is needed? Because without a parser tree, what happened? It is not possible to generate a grammar. Without a grammar, what happened? Compiler cannot perform of a other task. What happened? Compiler cannot perform of a other task. So the lexical syntax. Now we move into the semantic analysis. Lexical is also called as a what? A scanner. Followed by lexical, syntax, and semantic analyzer. What is the third part of the compiler? Semantic. The semantic what happened? After the token, after the tree generation, it is passed to the semantic. It will be checking and some other any substitutes are available. Quite simple. What happened? A equal to B plus C, because the same expressions are getting in the each and every places of the compiler. What happened? Compiler take the things. Suppose a printf enter the value of A or enter the value of B, enter the value of C, and followed by we do the operation where the enter file substitute. We know the structure of the C program and it's applied to the C compiler. Now C compiler will be getting involved. What has happened? In terms of C program for a addition program. What happened for addition program? Addition in C language. Because as a third year students, you are all very familiar with the syntax of the C language. What happened? A structure include the header files and int main, followed by a curly bracket, printf. Before that, what are the variables? B and C to get the values from the user, and we need to assign to the A semicolon. Because it's syntax for a declaring of a variable. Printf, enter the values of A, B and C. Fine. And what happened? We have a statement called A equal to the same expression, B plus C. Now counting, what happened? After the things we need to scan it. Scanf percentage %D BC. So that line will be getting the values of BC and assigning. What happens? Scanner %D B comma ampersand B ampersand C semicolon. The same line scanner. Now what happened? We declared a variable ABC and get the value from the user. And what happened? The value is BC. When the user supplying the value 10 plus 100, what is the output? 110. Got it? Now what happened? The operation A equal to B plus C. When you try to print A, what happened? Print A means it will be displaying what? content. How it is performed, we know it very well. So in the semantic analyzer, what happened? Checking the syntax. See here, the parser tree or abstract tree, syntax tree. We know what is the parser tree also, we know it, and abstract syntax tree in the sense the input form of the second phase of the compiler. Lexical analysis, syntax and semantic analyzer. Again, from this what happened? Okay. And students, just we see the simple form of the expression equal to A equal to B plus C. You see one more form of the things equal to position equal to assignment initial plus rate into 60. What we see in the previous thing, A assignment B plus C. What are the various substitute? Very simple, the same thing. A parser tree. How parser tree will be generated? See, it will be getting various information such as ID1, ID2 and ID3. Because what happened? Identify. These are the new symbols known to the when the compiler getting in and checking what happened. These are the new symbols similar to ABC. So what happened? The lexical, syntax analyzer, semantic analyzer. So with the help of this, what happened? It is getting into the other phases. What happened? The remaining phases: code generation, code optimization, intermediate code form of the generation. Any substitutes will be available. What will happen? We need to assign B plus C computation or initial plus rate into 60 to the position value. So here it will be finding what happened. Instead of ID, we can use a temp1, temp2 and temp3. And in terms of the finally what happened, the things no need to be getting into the machine understandable. So what happened? The CPU, we need to move the content in the form of a register. So what happened? The various instructions such as add, move, multiply, etc. See this expression what happened? Here multiply with the rate. How to multiply? Here is ID3 into 60. What happened? We using some register. Finally, the register need to be content, and again it to be plus, and etc. And finally, add, move, and finally, what happened? It to be assigned to the concerned operation. So see here, what happened? The semantic analyzer will be forming the things. So the intermediate three form, that is an intermediate code generator, will be generating a code in the form of a C here into F A B C. So the B is a token 1 and C token 2 and plus etc. token. What happened? Intermediate form. What is an intermediate form? See here, 3 address codes and RTL. That is a regular transition languages into float B. Again B is a token 1 and C is a token 2 and any value is getting in. So this is intermediate code generation. What happened? Very simple. Just we see the initial equal to position into rate, we add multiplication and movement, flowment. That is what happened? Opcode instruction. Followed by the what happened? What are the phases? Lexical, syntax, semantic, intermediate code generation, and followed by again a code generator. What is the code? See again I give the opcode such as move the content R1 to be moved, and again the content from R to move to R1 and move the value of A to the R2. And finally you come to the idea. What happened? These are the opcodes of the language. Which language? Each and everything. Because what happened? We are going to write of a compiler to of a 8085. It will be having 8-bit instruction. Finally it will be getting in terms of the what? The concerned 8085 instruction. See finally what happened? We see what is a compiler, what are the phases of the compiler, what are the importance of the compiler, how the things are generating. So what happened? What is a compiler, what are the phases of the compiler? So compiler is a system program. We come to the end of the session so that we have an idea. What is a compiler? Compiler is a system program which takes the input from the user and produces the output, and output need to be understood to the system. In the sense what happened? See the phases of the compiler, and again the compiler divided into two phases, front end of the compiler and back end of the compiler. N number of compilers are available. So we see the remaining things in the coming classes, how to generate a grammar and etc. Thank you for listening.